This introduction to SQL would be divided into a few parts. Okay, so today is going to be the first part, and then in the coming weeks we'll do other parts as well. In today's session, I've got this agenda. I'm going to take approximately 35 to 45 minutes, depending on how fast I'm able to go. So we're going to start with what exactly SQL means, what is the full form of it, and how do we use it, where do we use it, so on and so forth. We'll talk about different SQL statement types, GDL statements, DML statements, and DCL statements. So we'll talk about what they mean and what the full forms and what the application areas are. And then today, our focus area would be on DML statement, specifically of specific DML statement, which is select statement. So that's the agenda that I have today. Now, to start with what exactly SQL means, let me in fact open one blank slide so that I can draw and I can what it stands for and what it means. So, SQL, the meaning of, I mean, the full form of SQL is structured query language. Structured query language. Couple of things about SQL. So this is the language which databases speaks. Okay, variety of databases, whatever database that you're working upon, if it is a relation database, then they would be speaking in SQL. That means they would understand SQL terminology, they would understand SQL commands, and so on and so forth. Okay, it is a programming language, but it is not a procedural programming language. That means it is you cannot create a flowchart. So you can't create an SQL command, set of SQL commands to say that you open this box based on these commands, okay, or you keep doing this until this meets. You can't create those procedural programs just like how you do in C, C++, or any other established programming languages. This is a condition based language, conditional language. So where you specify certain conditions, and based on those conditions, it works upon on the database. Now, and the name itself is a misnomer because the name says that it is a structured query language, but you can do more than querying here. You can do all the three important tasks that are there in any that you normally do in any relation database. The three important tasks that you normally do in any relation database are: first is the creation of it, that means the design portion of it, okay, which is the design. The second is your population of data. Once the design is ready, that means once the structure is ready, then you populate, right? So data entry and data manipulation. Data entry, manipulation, and data query. All are part of population here. Then the third thing, which is very, very important, in fact, third, I normally put the query part not here, but I put the query part here. Okay. So these are the things that you do with SQL, right? These are the three main tasks that you work with, that you want to do with any database, any relation database that you create. Okay. So that's what happens here. So say, for example, you want to create a large database. A large database meaning, uh, say you work with you're working in a university and you got say 50,000 students there. So you would want to create a table for students. You may want to create a table for instructors. You may want to create a table for courses or assets that the university has, and so on and so forth. So all those are part of creating the design, the table schema. And once the design is ready, then you want to feed the data into it, right? So as and when a student registers or enrolls in the university, you would want to feed that student's data. As an instructor joins the university, you would want to feed the data of an instructor in the database. So that part is done using population here. Once all the data is entered in the database, right? Then as an analyst, what you want to do is you want to create, you want to answer a lot of business questions. Answer business questions meaning, say, who was the topper in 2013 MS in economics batch in this department, right? So that is a question. So that is a query that you can create, right? Or you can create, a very intelligent or a little complicated query as well, saying that what was the average score average economic score when a particular professor was teaching a particular class in a particular duration, right? So that again, all these questions are part of query. So as an analyst, you are very very worried about fetching the data. That means once the data is there, then how do we retrieve the data based on conditions? Those are part of query part. Those are part of query section. Okay. Now let's look at the commands which are there under creation. So there are three basic commands under creation: create, alter, and drop, right? With create, you create tables, you create relationships, you create columns in the tables, you assign primary key, you assign foreign key. If you understand a little bit about relation databases, so you do all the design related things or creation related things using create. Alter, once the table is created, right? Then if you want to add a new column to an existing table, so that you can do with alter and add. So there is a sub command within alter which is add. Then there is second sub command within alter which is alter, and there is third sub command within alter which is drop, right? So alter with add, that means, so say for example, if you want to add a column to an existing table, alter with alter, if you want to modify the data type or rename a existing column in the table, then you would use alter with alter. Alter with drop, if you want to delete a column within an existing table, then you can use alter with drop as well. Now in some of the databases, the commands here may be called a little different. Say for example, in some databases, it would be called as alter and modify. Instead of alter, you would have modify there. Okay, so that, these small parts, small things differ from database to database. But you see, based on my experience, I can tell you that one of the beauty of learning SQL is that it is universal in nature, right? So whatever commands that you learn, SQL commands that you learn in one database, most of them stand true or you can use them as it is in other databases as well. So that is why it is called as a universal database language, right? One of the other properties of data of SQL. Okay, because SQL is not, this language is not owned by any specific company. So one can use this command to interact with any relation databases that are there, right? So we got three commands under creation: create, alter, and drop. Okay, these are part of design statements. Then under population, we got another set of three commands: insert, to insert rows, records in the existing table of a database; update, to modify the existing data. I'm sorry, yeah. Insert, to insert rows; update, to update existing data; and delete, to delete rows based on conditions. Okay, insert, update, and delete. These are the three basic population data manipulation related commands that you can work on SQL. But remember, with these commands, you can't modify the design of the database. That means you cannot drop a table, you cannot delete a column in a table, you cannot rename a column in the table. You can't do any of those operations using population. So can't modify the structure. Okay, or design. When I say structure, that means schema, design, all are same things. Okay. Then we've got create a query. Under query, we just have one command which is select. And as an analyst, you are most concerned about this command because this helps you to retrieve data based on conditions, and it helps you. Select command will help you to answer those intelligent questions that you might be looking to answer once your data is ready, once your database is ready and it has a lot of data in it. So based on a lot of combination permutations, you can sorry based on a lot of combination permutations, you can answer using select commands. Okay, so these are the three basic SQL statement types: uh, design related SQL commands, population related SQL commands, and query related SQL commands. Right? There is one more way as to how we divide the SQL statement types. It's called as these ways. I mean these three different statement types: DDL, which is data definition language statement; DML, which is data manipulation language statement, and DCL, which is database control language statement. Data definition, data manipulation, and database control language. Okay, these are the three further statement SQL statement types, right? With DDL, you do creation and design related things, creation or design related things, as we had talked in the last slide. So there are three commands under DDL: create to create the structure, alter to modify the structure, drop to delete the structure. Okay. Using DML, data manipulation language statement, you do three things: populate the data, manipulate the data, or query the data. It's part of DML command itself. For population, we have a command called as insert. For manipulation of the data, we have two commands: for update to modify the data, existing data, to delete the rows. Okay, so update and delete, and then for querying, we have got select, right? Now, some of the samples of update could be, or some of these DML statements could be: update table student set full name is equal to Amit Kumar, where ID is equal to 3. So, if you look at this sample SQL command here, you would appreciate the fact that it is very English friendly, right? It is English friendly, but it is not completely English. Okay, so you can't just simply write any English statement that comes to your mind. Okay, it is English friendly, but it's not exactly English, right? So you have to follow certain structure, and that is where the name structured query language, right? So there is a structure, and hence you are naming it as structured query language. So update table student set full name is equal to Amit Kumar, where ID is equal to 3. So what this statement will do is it will go to the table student. In fact, you don't even have to write table here. Okay, it will be simply update student set full name Kumar, where ID is equal to 3. So what would happen in this query if you run this statement? In the student table, whichever row has ID is equal to 3, right? If ID was the primary key, then only one row would have ID is equal to 3. In that row, it will go and change the full name column's value as Amit Kumar. So whatever the existing value was would be overwritten with Amit Kumar under the full name column, where the ID is equal to 3, in the row in which the ID is equal to 3. Select full name from student where mtest is greater than 90. So in this query, if you run this query, then the action that it will take would be from the student table. That means the student table will open, and in whichever row, wherever we meet this condition, or which the rows which satisfy this condition, where the condition is mtest, that means mathematics test score value should be greater than 90. So in those rows, for those rows, it will display the full name values. So it will display one column, full name column, and the values would be here, the full names of the students who have scored more than 90. So in simple English statement, it would be like that. Now, database control language statement basically covers about what kind of people, or which people will have access to the database and what level of access they will have. So there are two things we do here, two commands that are here: granting the access and revoking the access. Okay. Normally, in any team that you would work, right, there would be database administrators who would take care of these database control language statements specifically, because they are admin related things: who has what level of access, how many people can concurrently access the database, or can run DDL commands, or can run only DML commands, or can run only select commands. So they can decide as to who has what level of access and who should not have access to what, right? So that is done by the database admin guys. Okay, so normally I don't cover DCL as part of SQL for analysts. Okay. Now, as I said before, there are three SQL statement types: data definition language statement, data manipulation language statement, and database control language statements. Now, what we're going to do is we're going to take a small case with us. Okay, the case is a very simple case. So it's a very simple database with only one table, and in that one table, the name of the table is student table. The fields: ID for student ID, the name of the student, the date of birth, the gender of the student, the class. H code means the house code, which house code student is coming from. Say, for example, red, yellow, blue, green, like we used to have in our school days. D code is the district code the student is coming from. Remission is the fact whether or not the student has paid his or her fees, right? If someone has paid the fees, then the remission since it's a logical, it's a yes no field. Logical meaning it's a yes no field. So if someone has paid the fees, then there will be a tick mark stating that yes, this person has paid the fees. Otherwise, it will be a blank checkbox. M-test, which is numeric mathematics test score, and in fact, I have got one more field here called as P-test, which is physics test score, which is also numeric. Okay, to with if you wish, physics test. Okay, P-test. So this is the table that we want to create. So what I'm going to do is I'm going to create. We'll discard this for now, and I'm going to go to the Access database because I'm going to demonstrate this just because Access is very simple to understand, and most of the people would have Access at their home. So because it comes as part of MS Office package normally. So I'm going to go to uh, I'm open. So what I've done is I've opened an Access database here. I see I already have that table, but I'm going to demonstrate as to how do we create that table. So I'm going to go to create, and I'm going to go to query design here. I'm going to close this show table option, and then here under view there is SQL view. So that's what I'm going to do. I'm going to again explain how to go to the SQL view, create query design, close this show table option that comes along, and then SQL view, and then you will have SQL view here, and it says select, right? But I'm going to start with create. So create table, and then the name of the table is student, right? And then opening and closing parenthesis. So what I'm going to do within opening and closing parenthesis is that I'm going to create those fields that I wanted to create in that table. Fields that I'm going to go back to my. So these are the fields that I want to create: ID, name, date of birth, sex, H code, D code, remission, and so forth. So let's create ID, and the data type of ID is integer, comma, full name. I'll not use name because name is a reserved keyword in SQL, so I can't use name. Full name, and then variable character. Variable character meaning it is a text value, and I'm assigning up to 50 characters that it can accept. DOB, which is a date value, right? Date. Then uh, sex, which is again say I can use again I can use varchar, and if I want I can write it as 6, and then class, which is again varchar, suppose 2 because I just want class, or I'll make it 3 because the way I'm looking at classes that a student can be from class 1A, 2A, 10th A, 11th grade A, section class number and the section code, which could be varchar and 1 only because it will be red, blue, green, and D code varchar. Suppose I want to restrict it to 6. Remission, boolean, M test, integer, P test, integer, and then if I want to create a primary key in here, so then what I'm going to do is constraint the name of the constraint, which is student underscore pk. The type of the constraint is primary key, and the constraint and ID is the primary key. So what I've done here is I've assigned this name to this constraint, but the constraint actually here is that it is the ID is the primary key, right? And then if I run this statement, and then it will work, right? Now here it's not going to work. Okay, it's not called as boolean. Uh, so see here it's not going to work just for one simple reason because the student table already exists, right? But if you had created in some other database, it would have worked, right? So the student table would look something like this in the design view. I'm going to go to the design view of the student table. Uh, So in the student table, you'll have all these fields: ID, full name, date of birth, sex, class, H code, D code, remission, M test, and P test, right? So these are the fields that would be created, and with the data types, okay, and with the data types, okay. So you can easily create that. All right. So the next thing that we want to do is, once the design is ready, once suppose this table is ready, the next thing that we want to do is we want to populate the data. Now, how do you populate the data in any database? Normally, typically, you would find something like this. You would have the data sheet view. So this view is called as the data sheet view. This view is called as design view. Right now, we are in the data sheet view, which is for entering the data. So here, you just simply have to write whatever ID and the full name. Start giving the data here: date of birth, sex, class, H code, remission. Since it's a boolean number, yes, no, sorry, boolean field, so it is coming as check mark, right? And then M test scores, and then P test scores, right? So this is how you would input the data. And for every new row that you want to create, suppose I want to create one more row here. It's very simple. I go to the next row here. I write any name. Say for example, I write Rita here. I choose the date of birth. Okay, whatever date of birth that I want to give. Say 1987, and she's a female, and suppose she's from 1B. House code is say yellow. Yeah, okay, and suppose district is HWH, and suppose remission, she has paid the fees. She scored say 97 in maths and 78 in physics, right? And my row is ready. This is how you're inserting the row if you're using Access only, right? Now, so that thing is ready. Okay. The next thing that we want to do is we want to now query the data. Okay. How do we query the data? Because as an analyst, you are more concerned about query. See, I'm going to cover the insert part and the create part in detail in other parts. Okay. But today our focus would be mostly on learning the select part, which is the querying part. Because as an analyst, you are more concerned about fetching the data, right? Because most of the time you will get the data which is already there and which has been exported from other systems. So most of the time the data is already there, and you are more worried about as an analyst to answer those intelligent business questions using select commands. So how do we go to the again SQL view? Again, I'm going to go to create here, go to design. See, in other databases it will be very simple. Most of the databases would have SQL view right in their first user interface. Okay, but SQL was not specifically designed for SQL SQL operation, and that is why it is a little hidden. So now I'm here. So now if you notice, what we have here is select, and then we have select, and then semicolon, right? Semicolon means it's the end of SQL statement. Okay. In SQL, semicolon would mean end of SQL statement, but here in Access it is optional, so I can get rid of it. Otherwise, whatever I had to write between select word and the semicolon, right? But I'm going to get rid of this, and I'm going to explain you how to write some basic commands. See, the basic structure of select statement is select from, and normally we use where to specify conditions if there is any condition that we want to specify. Now, say for example, we want to create a simple query. We want to retrieve all the student names, right? Names of the students who have scored more than 19 mathematics tests. Now, so the here under from what comes is the table name. From which table do we want to get this information, right? Now, so which table we want to get? We will get this information from. We'll get this information from the student table. So from student, right? And what is the condition that we want to specify? That M test value, be careful. See, SQL is not case sensitive, but it is spelling sensitive. So if you make an error in the spelling, it won't understand what field are you referring to. Okay, it is not case sensitive. So even though I'm writing these commands under in caps, but you could have written them in small as well, or you could have written them. In fact, you could have written all these commands in the same line as well. Okay, but normally when you're learning SQL from scratch, then I recommend that write them in different lines, because when you get error, and which you will definitely, it becomes a little easier to debug the code. So from student where M test is greater than 90, right? For those students, we want to print what? We want to print their full name, and we want to also print their scores. So full name, comma, M test. So what this command would do here is it will give you the full name and M test score of the students who have scored more than 90 in mathematics test. Now, once I've written this command, if I wish, it's optional here, I can put a semicolon after the end of SQL statement, or I can remove it since it's optional. So, and then I go and run this query. The moment I run this query, what happens is you will get this output, full name and mtest, right? Now, so since only two columns are being shown, just because we had selected only two columns in a select query. Now, if I want to go back to the select query, what I can do is I can select the SQL view from here, or I can select the SQL view from here as well. Okay. So since it's a query object, so I can go to the SQL view from here. If you right click here and if you save it, it'll ask for the name of the name of the query. Suppose this is a very simple select mtest 90 plus, something like this. So I can save it like that, and it comes under the student table, and it is shown as a query object here. Okay. So that's how it gets saved, right? So it's a very simple command that I've written here. So basically, to write this simple command, there are a couple of things that you have to be worried about. First, from which table this information. So you see, even though we write it like this, select from where. However, the system reads it from where. So first, it will open the table, and if there is any spelling mistake in the table name itself, or if the table that you have specified does not exist in the table in the database, then what would happen is it will give you, if you try to run this statement, it will give you an error saying it cannot find the input table students because there was a spelling mistake and it couldn't find it. So first command that gets executed from the system perspective is from, and if that table does not exist in the database, then it will give you an error right away. Once the table is there, it has found that table, then it will open that table, and then if there is any where condition that you have specified, then that where condition will be executed, and the rows which are which are meeting this criteria would be selected then, and then at the very end would the select statement or the select command would run here. Okay, so first is this, the execution sequence. In fact, I have written it on an Excel file here for you guys. So the execution sequence is very simple. First is from. Second is where, if it is specified, and in fact there are a lot of other clauses as well, group by, order by, and so on and so forth, that we would learn in the future seminars. So all those would be specified. All those would come here in terms of sequence as well. So from is first, and last is select. Just remember that select gets executed at the very end, and from is the first command that gets executed, right? So from student where mtest is greater than 90, select full name comma mtest, right? So what are the steps that we have seen in SQL? First, the table will open. We'll search for the rows which specify or which satisfy the condition, and then for those rows, it will print the column specified after select. So this is a very simple execution sequence that the system would follow, right? Now let's discuss some of the other basic SQL commands. So I'm overwriting. Normally, you should not be overwriting, but if you wish, you can. So from student, what we want to do is we want to print the average score scored by different students in mathematics and physics test. So select full name, comma, now p test plus m test divided by 2. The BODMAS rule applies here as well. Okay. So bracket, why I put these brackets here? Because I want, first I want p test plus m test to be added, and then I want that to be divided, the entire sum to be divided by 2 in order to find the average. Now once I run this statement here, so once I'm done with it, I'm going to run the statement. The moment I run the statement, it gives me the full name of all the students and their respective average score in mathematics and physics test. But if you notice here, the field name for this column, this average column, is a randomly assigned field name, EXPR1001. It's a randomly assigned field name that is coming in here, right? Why? Because you see, that field, obviously that average field is not there in our database, and we never mention as to what this field should be called. So here there is one more provision that what you can do is p test plus m test divided by 2 as average. So then what would happen is whatever command, whatever word that you have mentioned here after as, so this would become the column header once I run this statement. So full name and average and the full name and the average scores, right? So now it becomes even more meaningful, right? So again, I go back to the SQL command. So this is so what I was trying to portray here is that based on the output of a select statement or a query from the SQL command, you can do statistical calculations as well. Like I've done a simple mean here, simple average. You can find median. You can find any such formula or expression that you want to create. You can create here. Okay, so the output from the output you can create statistical report as well. Okay, now okay. The same here, say for example, I wanted to enhance this query a little further. Suppose I wanted to only select those students who have scored more than 90 as average. So I would write the average here again, p test plus m test divided by 2 and greater than 90. So the students, only those students would be selected who have scored more than 90 as average in the mathematics and physics test. Right? So that's what is happening here. Right? Um, okay. All right. Now, say for example, instead of selecting only specific columns here, what I want to do is I want to select all the columns of the students who are meeting this criteria. So what I can do is instead of one way is that I start writing all these columns as they appear in the student table one by one after select statement separated with comma, or I just use a simple command called as select asterisk or select star. Select star from students and whatever the condition is would mean basically that the rows that are satisfying the condition, for those rows we want to display all of their fields. That means all of their columns. So select star. So this would display only for those rows which are meeting the criteria all the columns that were there in the database or in the table, in the student table that we were writing this query for, right? So this way you can print all the columns information very quickly without having to write them individually. Okay. All right, guys. So very quick overview. I just wanted to give a very basic quick overview of SQL. So that's what we have done today. In the upcoming seminars that we would have on introduction to SQL, different parts, we would talk about little more advanced functions. We'll talk about how do you compare data, how do you extract data from large databases, how do you extract data from multiple tables together in one query, and how do you get rid of some data errors as well, like how do you clean the data as well in SQL. So we'll talk about all those things in the future webinars. Look forward to them. And guys, thanks for being there. I'm willing to take questions. I've got 5 more minutes remaining. Should you have any questions, I'm going to unmute you guys. So please use your microphone, or you can type in the chat window to ask specific questions related to whatever we have discussed today. All right, guys. So I'm open to take questions either through chat window or through voice as well. So please feel free to ask any questions should you have, and I'll take questions for the next couple of minutes. Any questions so far? So guys, what we have covered today, just to quickly recap, quickly since you guys don't have a question, so I'm going to quickly recap what we have covered. Overview of what SQL stands for, and yeah, very quickly what we have covered today is what SQL stands for and what are the different SQL statement types. We have discussed that there are three SQL statement types: DDL commands, DML commands, and DCL commands. DDL commands are data definition language statements with which you design the table. So there are three commands here: create, alter, and drop. DML commands, data manipulation, with which you work with the data, you manipulate, you update, you query the data. So there are again three commands here: insert for inserting rows, update for updating the existing data, select for querying the data, and then database control language statements with which you can grant or revoke the access. And we discussed a small case, very small case. Quickly, we saw some of the as to how do we create different fields in a table. So that means how do we create a table with different fields? How do we assign a primary key there, and how do we assign different data types, right? And then we did a couple of basic SQL commands as well. So that's what we have done today. And in the next session, as I said before, we'll go into deeper SQL commands, and we'll learn about more advanced SQL commands. Thank you, guys. The recorded session would be uploaded onto our YouTube channel in a few days. Okay, I've got one question from Vijendra here. Is the SQL command used in today's session named for all databases? Yes, most of the SQL commands that we have discussed today, Vijendra, would be applicable for most of the other relational databases like from Oracle or from other Microsoft database like MS SQL Server or IBM DB2 or MySQL, which is an open source. Okay, with little bit of tweaking. Every database comes with a small manual. Okay, most of the commands that we discussed today specifically, all of them could be easily used in other database relation databases. Yes. Any other questions from anyone else? All right, guys. Thanks for attending this short, very quick webinar or introduction to SQL.